This video is explaining about the vapor compression refrigeration cycle. I would say that more than 90% of applications in the global industry fall under vapor compression cycles. The other category is absorption cycles, which are less common in our context. However, there are a few examples that you can find and study. The core or major application in the air conditioning industry primarily relies on the vapor compression cycle. In this cycle, vapor is compressed, and the driving mechanism is the compressor. When examining the refrigeration cycle, it is essential to recognize it as a closed-loop system. A closed loop means that the thermodynamic properties of the refrigerant should return to their original states once the cycle is completed. If the refrigerant's temperature or pressure continues to increase with each cycle, the system will not remain stable, and it won't be considered a closed cycle. To achieve a closed cycle, the state of the refrigerant or the medium must return to the original state. Leaving aside the theoretical aspects, the refrigeration cycle comprises four main components. The compressor, as the driving mechanism, compresses vapor. It is crucial to understand that a compressor theoretically cannot pump liquid. It compresses refrigerant vapor into high-pressure, high-temperature vapor. The struggle for engineers and consultants is to minimize the compressor lift, the power absorbed by the compressor or chiller, to provide a certain amount of coolant capacity. This involves employing various design strategies, especially in modern design philosophies. The hot gas, known as high-pressure, high-temperature gas, travels to the condenser, a type of heat exchanger. As it passes through the heat exchanger, it is cooled by air or another medium. The heat is dissipated to the medium, and the hot refrigerant gas loses its heat. The third component is the expansion device. When the refrigerant liquid passes through this device, there is a pressure drop. What reaches the evaporator coil is the low-pressure refrigerant liquid. When air is blown through this coil from the room or space to be conditioned, the heat from the air is absorbed by the refrigerant. The low-pressure liquid tends to become vapor as it absorbs latent heat of evaporation from the air, resulting in cooled room air. Finally, the vapor is sent back to the compressor to initiate the next cycle. This completes the refrigeration process.